and then this is the drill bit actually, and then it spins, it rotates around at relatively high RPMs, and it sprays grout into the limestone. And because limestone is such a porous material, the grout is allowed to infiltrate inside the pores, and then that's how you get your strength. Next slide. And then that's how we look after it. So you get substructs, and these are the columns that we'd use. We'll have the 4 columns, and we'll do the thing on top.
Hello everyone again, my name is Mohammed, and I'm going to talk about the scheduling of our project. This network diagram shows us the first step we're going to take to start our project, which is basically the design and the engineering step. That shows all the activities we need for this step and how that's going to end. And now we're going to talk about the real scheduling we have. We use the software Primavera. That's what we prefer to make it look nicer and organized more. As you can see here, we have the Gantt graph on the right that shows the period that we need for each step, and then we have the tables with the activities. The Earth network, which is the real work we're going to do for the project, going to start about 5 months from today. Why we have this 5 months? Basically, we need the mobilization to move all the equipment we need. We need the contractor to review our report and our plan. We need the inspection company to see our design, and we need the surveyor to look at the site and make sure everything is fine and we can do our project on that place. After the earthwork, we're going to have the grade and the subgrade part, which is going to take about 8 months, because it's more dealing with concrete, so we need to give them more time for this. And then we're going to have our 4th step, which is the permanent drainage, which is going to take about 6 months as well. And then we have the Pitchman's concrete. It's about like 4 months as well. And then finally, we're going to have our safety and the legal documents to be done, and then we'll finish from there. For the environmental impact of our project, we use first of all, we start with using the GIS to find some information we need about the site. We visited the site to make sure that all the information we get is right and get reviewed and confirmed. We found out in the site that this site had a lot of heavy trees that need to be cut in, like a lot. So the first thing we need to keep in consideration is the trees removal. Then we have animals like snakes that need to be moved for the safety of the people and them. And we have the landscaping to make for the sides of the roads to make it look nicer and organized. Then we have the contamination testing we have to keep on monitoring for the environmental impact.
Now for the aesthetics, it's a very important factor because millions of people, whether it be residents or visitors, are traveling on our Florida highways, so we want tourism to be up. And making our bridges and stuff like this look very well. So for our retaining wall, we use a MSE, which is a mechanically stabilized earth, and that's because it's adaptable to cut and fill. Now we chose this hexagon on the walls for a specific reason, because simple, consistent patterns on bridges make for a nicer roadway as long as it's consistent, and you'll also see later in our pavement why it comes into play. Now for our trees, we decided not to add any trees because of safety. We didn't want anything necessarily parallel. But as far as where we're building the road, it's very lush with green and trees and bushes. So even if we didn't add trees, in the background there's always going to be beautiful trees and make it aesthetically pleasing. Now for our lighting, we chose a HID 250 watts. This is a picture of it on the left, the bulb. And we chose a full cutoff design because it maximizes efficiency, because it doesn't emit any light going upward, just down onto the road. And also for another lighting, we chose to put on the bottom of our columns of our bridges lighting that is emitted upward to also make it aesthetically pleasing.
Hi, my name is Camila Perez, and today we're going to be talking a little bit about the other 8 miles of the bridge. So for the rest of the 8 miles, the straightaways, we've decided to implement solar roadways. This is a very interesting and upcoming idea. There's only a parking lot and a small roadway in Netherlands existing at the moment, so we've taken this idea and hopefully be able to implement it to the straightaways of the bridge. So 8 miles is about 2 million square feet, and we're going to use about 14,000 panels. So you might ask, why solar panels? Well, as engineers, our main concern is safety. They're very safe. We'll explain later. The solar panels are very eco-friendly, and they provide road illumination during the daytime and during the nighttime. It also provides this intelligent highway system, which is referred to as microprocessors. They're small, tiny computers that are installed inside every single panel, and they connect within each other, also within the main powerhouse. Eventually, we hope to be able to power 2,000 homes. Each panel is about 110 pounds heavy, and the size is about 12 by 12 feet. Now, as Brendan was saying, the hexagon repeats itself. Here you can see the shape of a hexagon. Within the hexagon are smaller hexagons and smaller hexagons. I call it the hexagon inception. And the hexagons, they have 6 faces, and they're placed at 45-degree angles. There's a reason for that as well. Next, yes. So the most important thing about this is that it generates revenue. And eventually, the road will be not only paying for itself, but we will also be receiving extra money back. So it contains of 3 layers. The first layer, which is the surface, it's glass. The second layer here, you can see split it up in 2. So we have the electronics layers, and we have the the LEDs. And the bottom layer is the base layer, which is recyclable material. Next slide, please. Okay. So this light, this is the road surface, which is the glass. It's the glass material. Now, this is not regular glass, the kind of glass that you'd use at home on your windows for cooking. This is high-strengthened glass, so it has been treated for it to be very special. Also, it's transparent, so sunlight can come in and it can come out at those 45-degree angles. Anybody would be able to see them from any position. And it has enough traction, as you can see here in comparison to that man's hand. The traction is about the same as an asphalt or concrete road. So we have the middle layer, which is the electronics layer. They provide very important, the mini computers called the microprocessor board. They also provide the solar cells, which are actually called the photovoltaic cells, and the LED lights. And then we finally have the base plate. The base plate is part of our green movement that we're living in right now. So currently we have over 46,000 pieces of plastic floating around in our oceans. We could either leave them there and continue making this planet more toxic, or use them for something better. We can use them for the base plate. This is just as strong, and it is weatherproof, it's recycled materials, and it distribute powers between the roads and the homes, or between the roads and the business. So let's talk a little bit about the panels. The panels have this prism-like shape, as I was saying. They have 6 faces at 45-degree angles. The reason for this is it doesn't have to be a very sunny day like in Miami, which we wouldn't have a problem with that. But even in northern states, even in northern Europe or whatever it may be, where you don't see much sun for half the year, any sunlight that is available throughout the day, it will capture it immediately from any of the 6 sides, from any angle. Now, the glass that we're using is not just regular glass. The glass that we're using is 5 times stronger than regular glass. It's called tempered glass. And actually, bulletproof and bomb-resistant glass is tempered glass. So our roads would be able to handle pretty much anything. As I was saying, it also matches the traction of a regular road, whether it might be asphalt or concrete. So let's talk a little bit about the hardness. Here you can see the hardness of asphalt is 1.3, and the hardness of steel is between 6.5 and 7. The hardness of regular glass, plate glass, is between 5 and 6. But actually, the hardness of hardened glass can actually go up to 7 or more than 7. So we can consider hardened glass, tempered glass, to be stronger than steel. Oh, can you go back to something? Thank you. So it was tested to see, not just in a hardness level. Let's test it. Let's see how strong it can be. It surpassed the load testing, the impact resistant testing, traction testing, LED patterns, and other testings. The load testing, it can support 6 to 8,000 pounds. So I think that's pretty good. Yeah. So safety, why is this safe? For many reasons. First of all, as you can see in the picture, there's a moose theoretically crossing over the road. Whether it might be an animal, whether it might be a person in the middle of the day, in the middle of the night, the lights that we're providing are being provided from the road. So let's say, you don't want to run over a person, you don't want to have to run over an animal. Every time that anything steps on the road, these solar panels are sensitive, so they immediately light up. And the light is bright enough that you can see it in the middle of the day, so that when you're driving at night, you'll be able to say, there's someone on the road, you have to be careful. It does the same thing with accidents. If there is an accident ahead, it will warn you, not only using that method, but it also warn you with writing on the road, because we can say, we can paint on it. So we can deviate the roads as necessary. We wouldn't have congestion due to accidents, due to traffic construction, that wouldn't happen. And it would, mark a ring around it so drivers are aware of what's going on in their surroundings. So that brings us to illuminated roads. Well, they're very visible during the day. So during the nighttime, they're very bright. Sometimes they have to even be dimmed down. And, in the middle of the night, on a Tuesday night, you might not even have to, need these lights. So we might either dim them down or turn them off, depending on the amount of traffic going on. If there are any cars on the road, the solar panels will be able to detect this. So what it does is that for the half miles in front and behind of the car moving, it will carry along lines that will continuously light up. These lines go at speed limit, so make sure to go at speed limit. Next slide, please. So you might be thinking, well, this could be a little bit expensive. All right, so for one panel, it's $6,900, 12 by 12. And we have 8 miles, so that's about 2,000 square feet. Now, every square feet is $48. Our total would come out to be $97 million. So, this road would need very low maintenance. Oh, please keep in mind that the cost includes material, construction, maintenance, snow control, which we wouldn't need, that's extra heat. So our price would actually be a little bit lower than that. That's for northern states. And pothole prevention. So when you calculate the cost for an asphalt or concrete road, you calculate the cost, but you don't include these factors. So these factors are already included because in reality, you prevent a lot of these problems with solar roadways. Now, you might think maintenance. Well, in terms of maintenance, let's say a panel breaks. A panel breaks immediately before it breaks, the powerhouse knows it. If it's an electrical problem, they know when it's a potential problem coming. The computer can fix it itself. If it's a physical problem, let's say something falls on it, a tractor, an airplane, whatever it may be, all of a sudden, all of the panels around it are connected. They're all connected to each other using these small computers. And they will be able to warn the powerhouse that there is a panel that is not functioning. Immediately, a driver will come and replace that panel. That takes minutes. It doesn't even take hours or days, which is something that we have to pay for when we sit in traffic waiting for construction or waiting, late to work, whatever it may be. We have to pay for it anyway. That's already accounted for. In the topic of braking, let's say a glass breaks, and you might be wondering, well, this glass, would it be harmful for my car? Will I, go over it if someone's on the road? It's tempered glass, so it doesn't break like regular glass. It doesn't shatter. It's not going to cut your tire. It will break in form of bubbles, so you'll just going over a lump, not necessarily breaking your tires. So maintenance itself, it can be controlled, and it's very inexpensive. Now, in about 21 years and 8 months, the road will need to be refurbished. Not necessarily reinstalled, just refurbished, so just a little bit of refreshment. By that time, the road would have paid for itself. So yeah, it might seem a little bit expensive at first, but in less than 22 years, the road would pay for itself. You might wonder how. Well, right now in South Florida, the electric bill goes for about 11.6 cents per kilowatt hour. That's about $373,000 per month. So our average monthly bill is $180, and we could potentially power 2,000 homes 100%. That's how we would break even in less than 22 years. Let's say we wanted to help more than 2,000 homes. We wanted to be a little bit generous. We could help homes 50%. Let's reduce everyone's bills 50%. We could help more than 4,000 homes. But we really want to be more generous, so we want to help everybody around the entire city. Let's help 20,000 homes or businesses. We can reduce everyone's price 10%. It might seem like a small reduction, but if somebody comes to your house and tells you your electric bill is 10% less, that would be an interesting take. So I'm going to pass this on to Mike to talk about the final cost.
Alright, so guys, let's talk money. We have a team that has created pretty much something incredible that is pretty new to engineering, and we're happy about this because all of the costs on here are historical and based on engineering that we were able to do behind the scenes that are on our report. We hit the numbers very hard and we had to make a lot of strong decisions based on the type of bridge, segmental, for example, the Florida I-beams. And coming down at the end, we thought about the big step, which is the solar panels, and I think it pays off. It's something very important. So then for the last, like you said, for the last 8 miles, it would be all solar panels. And within 22 years, it would pay off itself. So we are Limitless Designs, and that's what we have for you guys. And I think it's something, it's a big step. And if a road can pretty much power itself and pay for itself, it's a road that it's worth every dime. Thank you guys.
That's open to questions from anyone in the audience.
Any questions, guys?
Well, how do you treat the stormwater on these glass surface on the road?
Go ahead, Fabio.
Yeah, the stormwater, well, first of all, it's one thing, the runoff coefficient of this road, we assume this is the same as Southpaw. So the stormwater will actually go into the catch basins, and then it will pass into a French drain filtration system. Now, if this water were to be discharged into the actual surrounding areas, it would have to be treated as per South Florida Water Management standards. So yeah, it would go into an exfiltration system and then a retention pond that we would have to build ourselves. There are no retention ponds in the area in order to remove the pollutants.
I remember about a year ago watching my Facebook news feed pop up with these solar panels, and the very first question that came to mind is maintainability. I guess did you guys compare the cost of the solar panels versus the cost of what it would to replace it with asphalt and concrete?
Well, in the terms of comparison, it's a little bit difficult to do, as I was saying, and when it comes to cost, there's different things that come into play for a regular road or a solar panel road. Also, in terms of maintenance, it would mainly be electrical, and it would mainly be done from somewhere else unless an exact solar panel had to be fixed, had to be exchanged. And this would require professionals. This would require electrical engineers and mechanical engineers. It wouldn't just be lifting something, putting it back in. So this would be a great opportunity to be able to give professionals a job. That's something that our economy is struggling with right now. So other than being green, I mean, there's tons of green benefits to it, but it would improve our economy greatly.
And definitely to add on to her point, so let's say that one panel right there has a problem. So if that panel has a problem based on whatever it is, a guy can come with his truck, put the signals on the back, lift up the panel without moving from his seat, placing it inside or in the back, and then putting a brand new one on and taking it back to the place where it came from, getting it fixed, and that's pretty much it. You got another panel, and that can take 3 minutes. So then you're holding up lanes for 3 minutes, and you're deviating traffic in the process that you're doing that.